In order to make it easy for you to access the private testnet, we have included it in our workspace, in our container. So this is this folder, which is included as a Git subtree. And the repository I'm including there as a Git subtree is this one, is woofpools cardano -private -testnet -setup. However, we are not using the main branch, but the Babbage branch, because we want to use Plutus version 2, which requires the private testnet to run on Babbage. And the version on the main branch still runs in the Alonso era. So this is a very nice project, and there are nice explanations and lots of options how you can configure it, but we will just run it in the default configuration, which I believe will spin up 3 nodes and create 3 users and set up 3 stake pools and provide initial funds to the users. In order for this to work, of course, you need a Cardano node. And we already had one from the very beginning in our setup, because as you recall, I used the Cardano CLI at some point, and that needed access to the testnet, so we had a Cardano node running in the background. However, that was in a different container that we combined with the main container via Docker Compose. So for this lecture, we have made that accessible. So now if in your workspace in a terminal you type Cardano node -- version, for example, that should be accessible. You will need to restart the container for this at the newest version. So do a git pull to get the newest version of the repository and then restart the container. And then the Cardano node should be available. Now to spin up the private testnet, it should be a simple matter of changing into this directory and then running one of the scripts that's already there. That's script/automate. This takes a couple of seconds, but it's amazingly fast. We don't need this and can close it. And we see our network is ready to use. It's running in the Babbage era. And in particular, we also see the node socket that we can point our Cardano CLI to interact with the testnet. As I said, the main advantage, at least for this lecture, of using the private testnet is how fast it's progressing. So instead of having to wait a week or 5 days for an epoch to pass, it's only a few minutes using this private testnet. One slight disadvantage of this is that if you know something about Cardano, how it works, how you run a node or how you operate a stake pool, there is this concept of KES keys that have to be renewed in regular intervals. So for the normal Cardano mainnet, that happens every couple of weeks, I believe. So everybody that operates a stake pool has to frequently, every couple of weeks, generate new KES keys and replace the old ones. And because this private testnet is so fast, this is not necessary only after a number of weeks, but happens after an hour or so, which means that if you take a long time trying things out, following the lecture, you might run into this problem that suddenly things stop working because your KES keys are outdated. So the easiest thing in that case is to just stop the testnet and start over again. Of course, you can also try to renew your keys. I can stop the testnet doing Control-C. And one thing that sometimes happens is that the nodes or some of the nodes are still running. So you should kill them in that case. Let me check with top. And I see no Cardano node is running at the moment, so that's fine. I have restarted the testnet and now leave it running in this terminal and open a new terminal. And first, to see whether everything works, I want to just do some interactions with it. So in this week's folder, I have this script folder with all sorts of scripts that we will use. So let me first navigate to that. One script I have here is query tip, which just uses, after setting the node socket to the node socket of the testnet, just uses Cardano CLI query tip. So we can try this. And we see the testnet is running, is 100% synced, and we are already in block 199. If we look into this testnet folder, here, Private Testnet, the subfolder, we see various subfolders. One is addresses, and here are our three users, the addresses, the payment addresses of the three users, payment 1 address, 2 address, 3 address. We also have staking addresses for those three users. In the stake delegator keys, we have the corresponding public and private keys. So for each of the three users, we have public and private payment key and public and private staking key. Let's forget about users 2 and 3 and concentrate on user 1. So first we can check how many funds it has. So there's the script query UTXO user 1, sets the node socket path, and then does a Cardano CLI query UTXO. Testnet magic of this private testnet is 42. And it just goes into this path and queries the payment 1 address. Let's try this. And we see user 1 indeed has funds, owns 1 UTXO, and let's count zeros. Seems to be 300,000 ADA. Another script will allow us to list the stake pools using Cardano CLI query stake pools. And we see the three stake pools listed with their pool IDs here. We can also check user 1's staking address with query stake address info user 1, which uses Cardano CLI query stake address info. And we see that, first of all, user 1 is indeed delegating to a pool. So it's the second one here. And we see that since the testnet is running, quite a lot of rewards have already accumulated, namely, in this case, 95,187 ADA. Let's try to withdraw these rewards. For that, I have this script, withdraw user 1. First of all, it takes one command line argument, namely a UTXO that we spent. Transaction always has to spend a UTXO. So we saw earlier here, UTXO is listed, so there's only one, so we will take that one then. Next, there is a peculiarity in Cardano regarding withdrawal of staking rewards, namely you can only withdraw all of them at once. You can't do partial withdrawals. So of course we just saw how we can manually look up how many rewards have accumulated. But because the private testnet is running so fast, this number can change quite rapidly. So if I do it manually, first look it up and then construct my transaction accordingly with the amount I just saw, by the time I'm ready to actually construct and submit the transaction, the number could already have changed and then this would fail. Therefore, I do this lookup not manually, but in the script itself. This is this line amount here. So I call this script we just executed manually here, then use the Linux JQ tool to extract this number. So that's then the variable amount. Body and signed up file names where I want to save the unsigned and the signed transaction to. So I created this temp folder here to put these artifacts. This is just for debugging. I set the path again. Now I build my transaction. It's in Babbage era, testnet magic 42. As change address, I just specify user 1's payment address again. That it should be saved to this file. Use the txin that the user provided when calling this script. And this is the crucial line which does the withdrawal. So it has to name the staking address. and the amount that we looked up at the beginning in this line. Then I sign, and this is also interesting because I need two signatures. First of all, I'm spending one of user one's UTXOs, and that sits at a pub key address. So the rule is if you want to spend something from a pub key address, the owner of that key needs to sign the transaction. So this is this first key here. Then I do a withdrawal, and from a staking address that's given by a pub key pair. And the rule of that is that if you do anything staking related with a staking address that's based on a key pair, you have to sign the transaction with the corresponding private key. So that's the second signature here. And finally, I submit. So let's try this. I need to give this UTXO here as parameter, #0, this #0 here. And the transaction was submitted. Now we have to wait a bit for it to go through, and then we should see that user one has more funds than before. Remember, it started with 300,000 ADA, so that should have increased now by whatever rewards had accumulated until I submitted this transaction. And we see indeed that the amount is much larger now. So now it's 449,702 ADA. So almost 150,000 ADA more than before. So we have seen how we can interact with the private testnet and in particular try out staking related things. And it's very nice and convenient because epochs pass so fast, so we don't have to wait long for rewards to accumulate. But of course, none of what I've explained so far has anything to do with Plutus. So next we want to look at how to combine Plutus with staking. So in particular, instead of using a stake address that's based on a public-private key pair, on a verification key and a signing key, we will create a stake address that's based on a Plutus script. So then instead of providing the signing key for the stake address, for example, for withdrawal, we will provide the script file, the Plutus script, and then we can put arbitrary logic, as always, into the Plutus script, which will then govern under which conditions we can, for example, do a withdrawal of rewards. So we will look at that next.